Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is path with maximum gold. So let's go to LeetCode and there you go. In a gold mine grid of size m cross n, each cell in this mine has an integer representing the amount of gold in that cell. 0 if it is empty. Now we need to return the maximum amount of gold you can collect under these conditions. So these are the conditions. Let's go over these conditions with an example. I'm sure you have already been through, the description and examples and everything. Let's just clarify what the problem is asking us. We are given a grid which has these integer values. 0 represents that there is no gold, but then 6 can represent maybe 6 gram of gold or 6 kg of gold. We need to return maximum gold under these conditions. So these are the conditions that we need to keep in mind while collecting the gold from this mine or grid, and we have to return the maximum possible gold under these conditions. So conditions are here. So let's go over these conditions one by one. Every time you are located in a cell, you will collect all the gold in that cell. All right, so gold in that cell you will collect. So basically if you are currently at this particular cell, so let's do the marking here. So this is 0 1 2 0 1 2. So this is a 3 by 3 grid. All right, it's a 3 by 3 grid. I didn't need to write it, but just wrote it. All right, so from your position you can walk one step to left, right, up or down, basically the grid, the directions, all these directions. So let's say if I am currently at 8, then I can go up, then I can go right, left and bottom. So these are the 4 directions that I can go. So left, right, up or down. This is done. Third condition, you can't visit the same cell more than once. So we will have to maintain a visited set. And by the way, you can walk one step to all these directions. So once you actually choose to, let's say, walk this direction, then you cannot take any of these directions, right? So let's say if I were to start somewhere like, let's say, I would say over here at 9, then if I'm taking, let's say, this direction, it's better to do it with this. So let's say if I was starting my traversal at 9, then if I choose to go up, which I of course would, and then from 8 I choose to go top, then I cannot go these and these 2 sides. So these 2 are prohibited. Like I can only take one of these 4 directions, right, at a given step. So this step is done. Then our 4th step is never visit a cell with 0 gold. So all these cells that you are seeing right here, we cannot visit them. So 4th condition is also done. Then last condition, and last and 5th condition is you can start and stop collecting gold from any position in the grid that has some gold. So this condition is also done. What simply the problem is asking us is that we have to collect the maximum gold starting at any position except it is 0, and then we have to return the path with the maximum gold. So let's say I were to start over here, then at this position I cannot start at all the zeros, so I am not even allowed to visit these zeros. So I will do a cross mark over here. So I cannot visit these zeros. Then I can start visiting, let's say 6. So if I'm visiting 6, then I can choose to go 4 directions. So I of course wouldn't go up because that's out of bounds. I cannot go to these zeros, so there's only one direction that I can go to, which is down. And once I'm here, then I can actually now choose to go to 3 directions, which is either this or this or this. So let's say if I choose to go basically this direction, and it would be better if I just do it this way. So if I choose to visit 6 and then 8 and then 7, now the I'm done visiting, I'm done taking completing a path. This path gives me total gold of 6 plus 7 is going to be 13 plus 8 is going to be basically 21. So that is the total gold this path is giving me. But what about if I start at 5? If I start at 5, then I visit 8, and from here I can go visit this 9. Then I am done visiting this one path. Then total gold here would be 8 plus 5, 13. 13 plus 9 would be 22. Alright, so that would be it. But how about if I were starting to visit at 7, then I visit 8, and then instead of visiting 6 or 5, I visit 9. Now this path, this yellow path, gives me a total gold of 7 and 8 gives me 15. 15 and 9 gives me, sorry, 7 and 8 gives me 15, and 15 and 9 gives me 24. So now if you see from all these paths, and I'm sure there are more paths in this, we see the maximum gold from these paths is maximum here is 24, and that is going to be my answer. This is my answer. So we will be solving this problem with a brute force approach, and which will be backtracking. So basically I will be running a DFS on each and every valid gold cell that has some gold, which is not 0. From there I will be running a DFS. That DFS will be traversing through this entire grid, basically making one decision, either top, bottom, or one of these sides. So basically it will be traversing through the entire grid and bringing me the maximum gold. Like it will be basically evaluating itself, that which path is giving itself a maximum gold, and then it will be returning me that value. So we will be actually, so this particular solution, if I just write it down right here, and I think it's okay, we don't have to delete that part. I'm just going to get rid of this right here. Alright, so just like we discussed, maximum of these will give me 24. That will be the answer. But here what I'll be doing is, this will be a backtracking solution. We start DFS at each valid gold cell. So that is my step 1. Then in DFS, which will be taking row and column position of the cell that we are starting, and then a visited set that will be empty in the beginning. But then in this DFS, what we are trying to do is return the path, or the sum, you can say sum of max values collection. I know the English here is just like being just super weird, but what I'm trying to say is, in this DFS we will be having our visited set, and we will only visit the cells that we have not visited so far. And since I'm starting at this position, so let's say in this grid I start basically 6, because in this case this will be the first value that I will start my path, because these don't matter. Then 6 will be going in here. I will be adding this to my visited set. After that I will be exploring all the neighbors of 6, so which is this and this, but then I will only be considering the valid neighbor, and then that neighbor will be basically called the DFS on. So I will call the DFS on this particular cell, which will take this particular value. But before that I will have a variable called best gold or most gold, whatever you want to say that, and then I will add that value to best gold, which will be max of best gold, or whatever DFS brings me from this position. So those 4 directions, we already know how to get around those 4 directions. All right, so time and space complexity for this solution would be, basically, since it's a brute force solution, it's going to be pretty bad, but that is the only solution for this that exists currently, because I guess this backtracking solution is the best so far. So for time complexity, we are going to have the time complexity of, let's say this R into C is, let's say if this is K, then the time complexity is going to be of K times, because for each of these valid Ks, whatever these, I'm talking about like all the values in this case, worst case R into C, this is the worst case, but in best case, K are those values which are non-zero. So K is non-zero values number. All right, now so K into 4 to the power K. The reason is that at most you basically visit all these 4 directions for each of the K, right? And then for space complexity, we are going to have this is going to be big of K, because you are visiting, at worst you end up visiting all the cell, which is basically R into C. All right, so let's write down the code for this. Let me arrange the editor. Okay, so let's get the dimensions for this. So row would be length of the grid, for column would be length of the grid, and we can say 0. Now I will have my for loop for R in range R, for C in range column, and then if this grid at this R and C is not equals to 0, because we are not allowed to visit cells that have the gold quantity as 0, I will call, so I will have a variable called answer. Answer initially would be 0, and then I will have answer equals to maximum of the answer, which is 0 initially, but then this DFS that I'll be calling on R and C, and then I am also providing it the visited set, and let me just say it's an empty set right now. Okay, and then finally I will return my answer. Now we write our DFS. So DFS will take the position of this cell R and C, row and column, and then visited set. Right now I am visiting a valid non-zero value because I have already checked it. So I will add it to my visited set, visited.add, and I'm adding this pair. But now I will declare so far the best gold. I would say so far the best gold would be the value at this position. So R comma C, that's what I'm starting with. Now I'm going to visit all the neighbors of this. So dr dc in basically this, all the 4 directions. So -1, that's going, that goes down, this goes up, then we can take right and then also take left. 0, -1. Now we'll find our new row and new column by adding R with dr and C with dc, and if this new R is greater than equals to 0 and new C is greater than equals to 0 and this new R is basically less than R and this new C is less than C, and most important thing, it's not in visited set. So this new R's and C, new R comma new C, not in visited, And most important thing, another most important thing is that inside my grid, this new R, this cell address, the row, and this new C, this value is not equals to 0. That means it's a valid neighbor that I can choose to visit. So I will add it to my visited set, right? So I will add it to my visited set, but that is not what I'm adding. I'm adding this right here. All right, so since right now I'm choosing to basically visit this, and it's a non-zero value, what I want to do is I want to actually basically assign my best gold. Basically my best gold would be maximum of itself, or whatever DFS brings me at this new position, but it will also take the visited set. All right, it will take the visited set. And then finally I will basically remove this from, I will return this best gold, but before that, here I will be actually removing this from my visited set. What am I removing? I'm removing this R and C pair. The reason is because this DFS will only run once, and what it's trying to do is it's doing the backtrack algorithm, where I am visiting from my current position, choosing to take one of the directions, and then from that direction I take another direction. Let's say from here I go up, from new position I go left, and then I'm done visiting everything. Then basically I'm done making one complete path. Then I will basically decide to track back to basically this position where I took up, and then from here I will have to remove this, so that maybe next time I might visit it from another path. So I will basically remove that. I will remove it so that later I might be visiting that from, I don't know, another route, because this best gold will be returned to this DFS, where it will be making a decision if it should keep that direction, or this best gold is already like a maximum value, and rather than taking this path, it might actually like trace back and take another path. I hope that makes sense. So finally, I think that will be it. And I'm just thinking maybe at this position we could start with this value, best gold at 0, and then add whatever we had at basically inside my grid. Okay, I think that will be better, because it's better that if you are adding this value like in the end, because so that you already explore you further values first, and then you come back and make a decision if I should take the value that have been returned to me from the top values. So let's try to run this on example. I have already zoomed out, and then best gold. Okay, yes, this will be inside here, not outside. Okay, so DFS and max, I think that is good. What did I do? Best gold is the maximum of best gold, or DFS, new RC. Yeah, awesome. Let's try to submit it. Although like the time complexity is not like great, but I guess it should be acceptable, because that was the best solution I could come up with, or I have found like other people have already solved it using this. Okay, so let's write down the time complexity. I already said time complexity would be big of k into k to the 4 to the power k, where k is r into c, and then for space space complexity, we are going to have k, where k is basically r into c. So r and c is the basically the dimensions of our grid, and this DFS itself basically it takes it has the choice of taking 4 directions, and it's running for all the grid if all the grids were non-zero, and then it's this is the time complexity of our DFS. And I think that will be all. And this 4 comes from this taking of 4 decisions and then running the DFS on top of that. So that will be all. Let's go back to our AlgoYogi and mark this problem solved. And now we have one more medium and 7 hard problems, and then we will be moving to dynamic programming. I know I've been talking about moving to dynamic programming for a while, but like I think graph was more important. I thought graph would be easier to wrap up before the dynamic programming, because dynamic programming is the killer. Okay, see you guys in the next video.